What I have here is a really crummy implementation of a bank account. Please don't critique this on how well it represents a bank account. Just let me use it as an example of a header file that might go through a series of changes. And what I'm going to do is, rather than make the changes live in front of you and possibly make typos, you can see I have 1, 2, 3, 4, 1, 2, 3, 4. I'm going to make changes by saying, now look at this other file. There's private things going on inside bank account. Obviously, bank accounts have a balance. We assign them some sort of arbitrary account number. And I have a trick for how to give each new account a unique number. I have a static, which is to say a shared or class member variable called max account num used. When you access something like balance or account num, which are instance member variables, you say the name of the instance, like Kate's checking account, dot balance if it were public, which it's not. When you want to access the max account num used, you say the name of the class, colon, colon, not dot, this is C++, colon, colon, max account num used. And all of the instances of bank account can share this individual piece of memory across all those instances. It belongs to the class rather than to any individual instance. Now we have an instance of transaction log. It's just a solid member variable of account. So whenever an account is constructed, a log will be constructed for you. And whenever an account goes out of scope, its log will go out of scope. We can control the way it's constructed with the parameters that come into the constructor or with the code that we run in the initializer clause of the constructor. Just so that you know what transaction log has, I have a constructor that takes an integer for the account number and stores that into the accnum private member variable. And I have a couple of public functions, add deposit and add withdrawal. And as it turns out, I have yet to code anything for add deposit and add withdrawal, making it a reasonably horrible log, but at least we have the member functions here in the class to know that they belong. Now I also use a customer pointer. I'm not controlling the lifetime. As it says here, it's just for access to methods. And I don't need to include all of customer.h. In fact, you'll see that there is no customer.h anywhere in this project. I haven't written customer. But in this circumstance, it's enough to know that customer is a class. And that way, saying customer star is legal syntax. It means this is a pointer to a customer. When we construct an account, all I do is in this initializer syntax. There's no body to the constructor. I initialize the balance to the bal that was passed in, the customer pointer to the pointer that was passed in, and the account number, I increment max account num used and put the new value, I increment first and then get the value. That's what I put into account num. And statics are initialized to 0 for you. So if I just say int x, that's not initialized to anything. But the statics are initialized to 0. So max account num used is going to start life at 0. And the first time we construct an account, it'll get incremented to 1, and then that new value 1 will get put into that account's account num. And for log, I pass the account num as the parameter to the constructor, which you saw was what the transaction logs constructor wanted. Bank accounts, you can deposit into them and withdraw from them. So you see deposit and withdraw. And they're both implemented here in line. They take an amount, and we first log the deposit, passing in the string today. Look back here, add deposit, sure enough, takes a string called date. Oh, that's cool. And as the comment says, golly, that should be a date, but anyway, and an amount. Then we increase your balance by the amount, and again, there's a comment thinking, shouldn't we keep track of this for service charge purposes or charge them a service charge on the top or something? Oh well, and then we will return your new balance after succeeding in making the deposit. Withdraw is exactly the same, except we're going to use add withdrawal in the transaction log, and we're going to reduce your account by the amount you've withdrawn. Now, I said from the beginning, not a super great implementation of a bank account, which is kind of not the point. I can come back to here and show you some code that exercises account 1 here. I make one with an opening balance of 0, and since it takes a pointer, I can pass null pointer. If I'd implemented this in any kind of intelligent way, I'd probably make sure that you passed me a real customer, but for now the compiler won't object to the code I've written, which just stores that in my customer pointer. Then I deposit $50 into that bank account. I make another one, and I deposit $150 into that one. And if we just run to this point, you can see that A11 has a balance of $50, which makes sense because we opened it at 0 and then deposited 50 into it. And it has an account number of 1. A1 underscore 2 has a balance of $150 because we deposited $150 into it, and it has an account number of 2, which makes sense. We created 2 accounts, and max account num used is now bumped up to 2. So this code, rudimentary as it is working. Now, if I'm the consultant and I come in to try to fix this up, the first thing I don't like is having this deposit and withdraw code inline in the header, especially in a circumstance where thousands of other files are all going to be including account.h. Every time we make any kind of change to the code for depositing and withdrawing, we're changing the header file and triggering a recompile. So let's get sane about that and take those functions and move them into a CPP file. So in account2.h, I now are just saying I have this function called deposit, I have this function called withdraw. I've also taken the code for the constructor out of the header file. So if you look in account2.cpp, this is basically just what we had in the header. We just moved it in here. So I'm initializing all of the same things on the initializer syntax of the constructor, and I have the same 4-line bodies complete with their little plaintive comments that I had in the inline inside the header file. Now I can change this code. I can deal with the string date issue. I can remember to accumulate something about service charges. Maybe in here I can even make sure that you have enough money in your account to authorize a withdrawal. You know, I have $50, I'd like to withdraw $1,000. That probably shouldn't succeed. I can make all these changes in account.cpp, and none of them will require changing account.h at all. So that is an improvement. But it's not the end of the story. Let's take a look in account3.h. In here, I've decided to start trying to write deposit and withdraw, and I've realized as part of that I need this little helper function, build date string for today. Here's the code. You can see that deposit is now using build date string for today, and so is withdraw. Alas, as the comment says, it needs work. But this function, build date string for today, it's private. The code out here in pimple.cpp cannot call it. I've got some account 3s kicking around. Here's one. If I say account3 underscore 1 dot, let's try this, build date string for today. Error. Function account3 build string for today declared is inaccessible. Absolutely right. It's a private function. I shouldn't be trying to call it. Well, given that I can't call it, it seems really unfair that adding it into account3's header file would trigger a recompile of everybody that included the account header file. But that's just the way life is. And so especially as you move to a more agile approach in C++ development, where you are going to go in and add a method, especially a little private helper method, do a little refactoring, change the names of things, you don't want that to trigger this recompile the world. And yet, most of the time, unless you take measures to prevent it, that's exactly what happens.